Hello lovely viewers, welcome back to Kunko Academy. I would like to recommend that if you are new to this channel, you like and subscribe, and also you put us on post notification so that you always be notified on every new video uploaded. So in the previous tutorial, we talked about continuity of functions of several variables, and also we talked about differentials of functions on several variables, that is partial derivatives. And with partial derivatives, we considered functions with two variables. In this video, we are going to consider partial derivatives on functions with three variables, and also partial derivatives involving quotient rule, and also the partial derivative of higher order. Now I have here two examples. Now the first example is f of x of y of z. That's the function has three dependent variables, that is x, y, and z, and the function is defined by x squared y plus cos of x squared minus y z. Now we are going to perform the partial differential of each of the variable. Now let's start with the first variable, that is s. So the partial differential of the function with respect to x. Now we could see that in this function we have the expression x squared y plus cos of x squared minus y z. In the previous tutorial, we talked about partial derivatives, that is whenever you are differentiating a function with respect to a variable, you treat the other variables as constant. So now in this term we have x squared y. Our value we are concentrating on is x, so therefore our y is going to remain as a constant, and we are going to differentiate x squared. So now in differentiating x squared, we are going to get 2x. Then now our y is constant, so it's going to be maintained, that's 2xy, plus the term here is cos of x squared minus yz. So now first of all, we need to differentiate the function in the cos function before we differentiate the function of the cos as whole. So now the function in the cos function is x squared minus yz. So as usual, we are differentiating with respect to x, so therefore we are going to concentrate on x. So differentiating x squared minus yz, we are going to get 2x for the differential of x squared, but our y and z, we don't have any x term, so therefore the differential is going to be 0 because the y and z is going to be treated as a constant. Now we are now differentiating the whole function. Now in differentiating the whole function, we are going to get negative sign of our function, and our function is x squared minus y z. So now we are going to apply the same idea in the partial differential with respect to y. So now with respect to y, we are going to treat each variable which is not y as a constant, so therefore our x squared here is going to be treated as a constant. So differentiating y, you are going to get 1, so therefore the differential of the first term is going to be x squared plus the differential of the expression in the cos function, that's x squared minus yz. Now differentiating x squared with respect to x gives us 0 because there is no y variable there, and differentiating yz with respect to y will give us negative z. Now this negative z you are also going to differentiate the whole function. Get negative sign of the function x squared minus y z. We are going to do similar one for z. So now with the z, I'm going to leave it to you as a problem for you to go through. Now let's move on to the second example. So with the second example, we have a function, and that function is represented with a fraction with two expressions. Now the numerator is x squared y minus 4xy, and the denominator is x minus 3yz. So now let's consider the partial differential of g with respect to x. So now we need to note that this expression is a fraction, so therefore, or it's a quotient, so therefore we are going to use the quotient rule. And we already know from calculus 1 that our quotient rule is v u prime minus u minus u v prime all divided by v squared. So now our function is represented as u over v. So now from the function, our u is the numerator and our v is the denominator. So now we are differentiating this function with respect to x. We are going to apply the same idea from the quotient rule to differentiate this. So now from the quotient rule, we have v, and our v is given by x minus 3yz. So we have our v to be x minus 3 y z. That's our v. So now with our u prime, we are differentiating our u with respect to x. So therefore, differentiating the u expression, that is x squared y minus 4xy, differentiating x squared y with respect to x is going to give us two x y. Now 2xy, differentiating negative 4xy is going to give us negative 4y. That is v u prime. So now minus u v prime. So our u is the whole of this expression, that is x squared y minus 4 minus 4xy v prime. So our v is given by x minus 3y. So differentiating with respect to x here will give us 1. and now the other expression will give us 0 because there is no variable which is x inside. So therefore all this expression divided by v squared, and all v is x minus 3 y z all squared. That's the partial differential of x. Sorry, the partial differential of g with respect to x. So now you can go through this procedure to compute the partial differential of g with respect to y, as well as the partial differential of g with respect to x. So now I'm going to leave this to you, my lovely viewers, to go and do the partial differential of g with respect to y and the partial differential of g with respect to z. Now let's move on to higher order derivative, that is partial derivatives with higher order. So now what do you mean by partial derivatives with higher order? Now in the previous tutorial we just did only the first partial derivative, that's fx fy. Now in this tutorial we are going to consider higher derivatives. So we are going to consider f x x f x y f y x and f y y. That is, we are finding the second differential of the function given. So now our function f of x of y is given by x e to the power negative 3y plus sine of 2x minus 5y. First of all, for us to compute this four expression, we first need to compute for the partial differential of f with respect to x and the partial differential of f with respect to y. So therefore the partial differential of f with respect to x is going to give us, so we are going to treat this function here in terms of y as a constant, then differentiate x. Now in differentiating x we get 1, multiplying by this we get e exponent negative 3y. Now we apply it to this expression by differentiating the function in the bracket with respect to x, and that's going to give us 2. Now we have cos of the 2x minus 5y. Now we have f of x, that's the first derivative. Let's consider the next derivative with respect to x again. So that's going to f of x. So now we are differentiating this with respect to x, and now our function here is only in terms of y, so therefore this term is going to be 0. Now differentiating this with respect to x, we already have 2 outside. Now differentiating the function in the bracket with respect to x will also give us 2. Then now differentiating the whole function will give us negative sine of 2x minus 5y. Now we are transferring this same idea by differentiating the first derivative with respect to y. So now if we differentiate e to the power negative 3y with respect to y, because the function is in terms of y, we are going to get negative 3e exponent negative 3y. Then now we have this expression, so 2 is already there. Now differentiating the expression in the bracket with respect to y is going to give us negative 5, and now differentiating the whole function give us negative sine of the expression 2x minus y. So now find the partial differential of f with respect to y, and after that you move on to the partial differential of f with respect to y with respect to x, and also the partial differential of f with respect to y with respect to another y. I'm going to leave this as a try work for you, and I know today I've given you a lot of try work, but do all to go through it to enhance your computation skills. Thank you for your audience. See you in the next tutorial. Bye.